Welcome to Deep Sleep Documentary. Before we begin, take a slow breath and remember to drink a little water so your body can settle into the calm of the night. Tonight, we travel into the quiet glow of the Aurora Borealis, a place where science, mystery, and gentle beauty meet in the sky. Let your mind drift as the colors unfold and allow this story to guide you into a state of deep rest. If you enjoy calming documentaries like this, you can subscribe to the channel. It helps you find these stories again whenever you need a quiet moment. And if this video brings you peace, a simple like can help others discover it too. Thank you in advance for your support. Now, let's continue into the documentary. There are certain nights when the sky seems aware of its own existence. Nights when darkness becomes something more than an empty space. At first, everything looks calm. A quiet, star-filled sky, stretching above frozen landscapes and distant mountain silhouettes. Then, slowly, almost shyly, a dim green glow appears near the horizon. It's faint, fragile, like the first stroke of a painter's brush on untouched canvas. But with every passing second, the glow grows stronger, rising, stretching, changing shape. And as it expands, you begin to feel as though the sky is breathing. This delicate and mesmerizing display is the Aurora Borealis, the northern lights. A natural phenomenon so beautiful and so improbable that even with all our scientific understanding, it still feels magical. People travel thousands of kilometers to witness it. Yet some lucky individuals living in places like northern Norway, Iceland, Alaska, Greenland, or Canada can step outside their homes and see these living colors dancing above their heads. The aurora appears high above the Earth, typically between 100 and 300 kilometers above the surface, far higher than any airplane can fly. Up there, the air is incredibly thin, the temperature drops to extreme lows, and the atmosphere is quiet, still, and empty. It is in this silent, almost unreachable part of the sky that the lights are born. And though the aurora looks calm, the story behind it begins in a place far more intense, on the surface of the sun. The sun is constantly releasing a stream of charged particles known as the solar wind. These particles travel at incredible speeds, anywhere from 300 to more than 800 kilometers per second. Most days, the solar wind flows steadily, almost like a cosmic breeze. But when the sun becomes active, during events like solar flares or coronal mass ejections, the flow intensifies dramatically. Billions of particles escape into space, racing toward the planets. Earth is protected by a huge magnetic bubble called the magnetosphere, a force field generated by our planet's molten iron core. Without this magnetic shield, life on Earth would be impossible. It deflects most of the solar wind, guiding it around the planet, the way water flows around a stone in a river. But near the north and south poles, the magnetic field bends inward. These are the only places where solar particles can enter the atmosphere. When they do, that's when the sky begins to glow. The light itself is created from collisions. High-energy particles from the sun crash into atoms of oxygen and nitrogen in the upper atmosphere. When these atoms absorb energy, their electrons jump to higher orbits, and when they fall back, they release that energy in the form of visible light. Different atoms at different altitudes produce different colors. Green, the most common color, produced by oxygen around 100 to 150 kilometers altitude. Red, rare and delicate, produced by oxygen above 200 kilometers. Purple and violet, created by nitrogen lower in the atmosphere. Blue, also nitrogen, appearing during very strong displays. Sometimes all these colors mix, forming curtains of shifting light that ripple like fabric in a soft breeze. Scientists can now measure the aurora with satellites, magnetic sensors, and high-speed cameras. They can predict auroral storms, estimate their intensity, and identify their origin on the sun. But even with all this knowledge, no measurement can capture the feeling of standing beneath the lights. Imagine the scene. It's late at night, temperatures below freezing. Snow covers the ground, soft and untouched. The air is crisp, still, almost unnaturally quiet. And then above you, the sky suddenly opens. Green ribbons spiral across the horizon. They twist, stretch, and shimmer as if they have a life of their own. A faint hint of purple outlines their edges. The movement is so slow and graceful that it feels like time has settled into a gentler rhythm, and the aurora is completely silent. Even the brightest, most powerful displays make no sound at all. You watch in stillness as the patterns shift, fade, and return. The lights appear to fall like glowing rain, then rise again like mist. Some arcs stretch across the entire sky, forming giant halos. Other times, the aurora gathers overhead, swirling into what observers call a corona, a radiant explosion of color that seems to descend toward you. Because the aurora is so tightly connected to the Earth's magnetic field, it appears most often inside the auroral oval, a ring-shaped zone surrounding the magnetic pole. In the northern hemisphere, this oval passes over countries like Norway, Sweden, Finland, Iceland, Russia, Canada, and Alaska. People in these regions can see auroras dozens of times each year. Farther south, the aurora is rare, but not impossible. During very strong solar storms, the lights can be seen in lower latitudes. Historical records mention auroras visible as far south as Spain, Italy, and even the Caribbean during extreme solar events. But even if the aurora is predictable in a scientific sense, it remains unpredictable in an emotional sense. Every display is different. Sometimes the glow is faint, like a distant city seen from across a lake. Other times, the entire sky ignites in bright waves of green, purple, and red. Knowing these details makes the experience richer, not less magical. The idea that tiny particles from the sun travel millions of kilometers, reach our planet, slide along magnetic field lines, collide with atoms in the atmosphere, and transform into dancing light. It's a reminder that the universe is active and alive, that the Earth is not just a planet floating in silence, but a place constantly interacting with its star. And for those who watch the aurora as a way to relax, to dream, or to fall asleep, the phenomenon offers something unique. The movement is soothing, the colors are gentle, and the knowledge behind it, the science, the distances, the interactions, adds a quiet sense of wonder. It is beauty with meaning. Night after night, for thousands of years, people have looked at the aurora and felt the same emotions: peace, awe, and curiosity. Long before satellites and sensors, ancient cultures created stories to explain the lights. They saw them as messages from gods, spirits, or ancestors. Some believed the aurora was a bridge between worlds. Others thought it was a sign of good fortune or a warning of change. Today, we know the true cause. But standing under the lights, it doesn't feel like a scientific event. It feels like nature expressing itself gently. A slow celestial dance, written by forces far beyond our control. And this is where our journey begins. With a sky that glows, a planet that protects us, and a star whose energy reaches across space to paint the night with color. In the next chapter, we'll go deeper into this connection, exploring how Earth's magnetic field shapes the aurora, and how this invisible force guides the colors we see. For as long as humans have wandered under northern skies, the aurora has been a companion. Mysterious, unpredictable, and impossibly beautiful. But understanding it, truly understanding it, required centuries of curiosity, courage, and observation. It required people willing to travel into the coldest corners of the world, to spend long nights waiting, watching, and writing. Every expedition that set out to study the aurora carried not only equipment, but also wonder, patience, and a desire to touch the edges of the unknown. In the early days, explorers did not have sensors or satellites. They had only their eyes, their notebooks, and their instincts. Some of the first written descriptions of the aurora came from travelers who ventured far north, long before the science existed to explain what they were seeing. They recorded shimmering arches, rivers of green, curtains that moved as if stirred by a silent wind. These accounts were poetic, sometimes fearful, sometimes hopeful, but always honest. Many of these early observers believed the lights were messages from spirits or signs of weather to come. Their interpretations may not have been scientific, but they formed the very first foundation of our understanding. Simple observations of what the sky was gracious enough to reveal. As centuries passed, curiosity deepened. One of the earliest scientific attempts to explain the aurora came from a Norwegian explorer named Fridtjof Nansen. In the late 1800s, he embarked on a daring Arctic journey. His ship, the Fram, became trapped in sea ice, drifting slowly for years across the top of the world. During those endless polar nights, Nansen watched the aurora almost daily. He wrote about the way the lights appeared suddenly, the way they stretched from one horizon to the other, the way they shifted shape like living beings. His careful notes became some of the most detailed observations of the time. And although he did not solve the mystery, he provided something precious: consistency. True scientific documentation, night after night, even when the cold made his hands tremble as he wrote. A few decades later, another Norwegian, Christian Birkeland, changed everything. He was the first person to propose that the aurora was caused by charged particles from the sun interacting with Earth's magnetic field. At the time, his idea was revolutionary, almost unbelievable. Many dismissed him, but Birkeland was persistent. He organized expeditions to remote northern stations, dragging heavy equipment through snow and darkness so he could measure magnetic disturbances during auroral events. He spent nights alone in crude shelters, lit only by lanterns, listening to the wind and recording every tremor in Earth's magnetic pulse. Eventually, he built a device he called the Terrella, a small metal sphere representing Earth. By shooting electrons at it and placing it inside a magnetic field, he produced glowing rings near the poles, tiny artificial auroras. It was the first time anyone had ever recreated the lights. The scientific world finally began to understand what Birkeland had been seeing all along. The aurora was the visible footprint of a cosmic interaction between the sun and our planet. His work shaped modern space weather science, and today, spacecraft still rely on principles he discovered alone in the Arctic night. As the 20th century unfolded, expeditions into the auroral zone became more sophisticated. Scientists set up observatories in Alaska, Canada, Scandinavia, and northern Russia. They built cameras capable of capturing the lights in slow film, revealing motion too fast for the human eye to follow, and colors too faint to be seen clearly in the moment. Some lived for months in isolated research stations, surrounded by snowfields that reflected the glow like a mirror. In their journals, many wrote not only about the science, but also about the profound quiet they felt while watching the sky. How the aurora made the world seem both immense and intimate at the same time. When satellites finally arrived, the story of auroral exploration expanded upward into space. For the first time, humans could observe the aurora from above, watching it spread like a glowing oval over the polar regions. Spacecraft detected streams of particles flowing along magnetic field lines, confirming decades of ground-based hypotheses. The lights were not just a visual show, they were the living trace of Earth's magnetic environment, a visible conversation between our planet and the sun. One of the most influential spacecraft in auroral research was NASA's polar satellite, launched in 1996. It captured images of auroras forming, intensifying, and shifting shape in response to solar winds. These images revealed that the aurora was part of a much larger structure, a global dynamic system that connected space and Earth in ways scientists were only beginning to understand. These expeditions, though conducted with machines rather than human travelers, were just as brave, just as transformative. They carried forward the same spirit that had once guided explorers across the Arctic ice. Today, auroral research continues with missions like Themis, Cluster, and the Japanese Hisaki satellite. Instead of notebooks, scientists use particle detectors and magnetometers. Instead of lanterns, they use solar-powered observatories. But at its core, the work is unchanged. It is still about looking upward, still about listening to the sky, still about waiting for something ancient to reveal itself again. Modern expeditions are quieter, more precise, but the wonder remains the same. Even tourists have become part of the story. In Iceland, Finland, and Alaska, thousands of people travel each year in hopes of seeing the lights. They join guided tours across frozen lakes, hike in silence through snow-covered forests, and stand wrapped in blankets beneath the stars. Some of them capture photographs that travel around the world, inspiring others to learn more about the science behind the glow. In their own way, they are explorers too, modern-day witnesses adding their experiences to a centuries-long story. And in the quiet spaces between scientific breakthroughs, something gentle remains. The aurora continues to move people, whether they are researchers analyzing data or travelers seeing it for the first time. Every expedition, every mission, every lonely night in the Arctic has added another layer to our understanding. They have shown us that the lights are not random, not supernatural, but part of a natural rhythm that connects Earth to the sun. Yet despite this understanding, the aurora never loses its mystery. Even the scientists who know it best describe it with awe. They speak of nights when the sky erupted suddenly, or when faint colors turned into breathtaking spirals. They speak of the feeling of witnessing something both fragile and powerful, something that humbles even the most knowledgeable observer. In the end, the story of auroral expeditions is not just a scientific narrative. It is a human one. It is the story of people who were willing to step into the cold, to stay awake through the darkest hours, and to follow a light that asked for nothing but attention. Their efforts transform the aurora from a beautiful mystery into a beautiful explanation. One rooted in physics, in solar winds, and in the quiet, invisible structure of our planet. And yet, even with all we know, the aurora still behaves like a story told in light, unfolding, shifting, revealing itself gently. The explorers who chased it across ice and sky did more than gather data. They preserved the sense of wonder that the aurora inspires, a wonder carried forward each time someone looks up and sees the colors drifting above the horizon. If the Aurora Borealis is the visible breath of the night sky, then the magnetosphere is the silent architect behind it. It is invisible, enormous, and constantly in motion, a protective shield shaped by forces deeper and older than human history. Most people will never see it, never feel it, and never think about it. Yet without this unseen guardian surrounding our planet, the northern lights would not exist, and neither would we. To understand the aurora more deeply, it helps to imagine Earth not as a quiet sphere drifting in space, but as a living system interacting with everything around it. At the core of our planet, more than 2,800 kilometers beneath our feet, lies a churning ocean of molten iron and nickel. This restless, swirling metal generates electric currents, and those currents create Earth's magnetic field, a phenomenon known as the geodynamo. This magnetic field extends far beyond the surface, reaching tens of thousands of kilometers into space. As it stretches outward, It forms a shape similar to a giant teardrop. On the side facing the sun, the field is compressed, squeezed by the constant pressure of the solar wind. On the night side, it stretches into a long magnetic tail, sometimes reaching farther than the orbit of the moon. This entire structure is what scientists call the magnetosphere. Even though we can't see it, we are living inside a vast magnetic bubble. The magnetosphere is constantly shifting, pushed and sculpted by the solar wind. Every second, particles from the sun collide with this magnetic shield at incredible speeds. Some are deflected instantly. Others slide along the field lines like beads on a string. And some, the most energetic particles, slip through openings near the poles, where the magnetic field dips closest to Earth's atmosphere. These openings are the gateways through which the aurora begins. To picture the magnetic field, imagine a giant bar magnet placed through the center of the Earth. Magnetic field lines curve out of the South Pole and loop back into the North Pole in elegant arcs. These lines are not physical objects, but they behave almost as if they are. Charged particles follow them, spiraling along their paths until they collide with atmospheric atoms at high altitudes. The collisions create the shimmering light we see from the ground. And this is why auroras form in oval shapes around the poles. The magnetic field guides everything: the shape, the location, and even the intensity of the northern lights. But the story becomes even more interesting when the solar wind grows stronger. During periods of intense solar activity, the sun releases enormous bursts of plasma into space. These events are called coronal mass ejections, or CMEs. When a CME reaches Earth, the pressure on the magnetosphere increases dramatically. The magnetic field bends inward, storing tension like a stretched bowstring. Then, when the pressure becomes too much, the magnetosphere suddenly snaps back, releasing energy in a rapid, explosive motion. This process, known as magnetic reconnection, sends waves of charged particles deep into the polar regions. And when these particles collide with oxygen and nitrogen, the aurora brightens and expands, becoming far more vivid, colorful, and dynamic. This is when the lights dance with unusual speed, twisting and folding into spirals, curtains, and ribbons. It is when the sky feels alive. Some auroras are gentle, glowing like fog illuminated from within. Others are intense, bursting into the sky with sharp streaks of green and purple. And though they look serene, they are the result of forces far more powerful than lightning, hurricanes, or volcanoes. Every bright aurora is a reminder that our planet exists in a continuous interaction with the star that sustains us. Another important part of this story is that Earth's magnetic field is not perfectly stable. It drifts, fluctuates, and slowly changes over time. The magnetic poles wander, sometimes moving several kilometers per year. These shifts alter the shape and position of the auroral ovals. 1,000 years ago, people in areas farther south may have seen auroras more often than they do today. 1,000 years from now, the auroral zone may shift again. Earth's magnetic field also reverses polarity occasionally, a process that happens, on average, every few 100,000 years. During such reversals, the field weakens before rebuilding itself in the opposite direction. Scientists are still studying how auroras might behave during these periods of magnetic transformation. But the idea that the sky's colors could change as the planet's magnetic structure evolves adds another layer of mystery to the lights. Even today, the magnetosphere remains one of the most complex and dynamic systems in our solar system. Satellites like NASA's Themis mission and the European Space Agency's Cluster spacecraft have spent years studying it, trying to capture the precise moment when magnetic reconnection occurs. These missions observe the magnetosphere, like weather satellites observe clouds, tracking, measuring, and mapping its shape as it responds to the solar wind. Thanks to this scientific work, we now know that the magnetosphere is not merely a barrier. It is a conductor, a sculptor, and a translator. It takes the sun's energy, raw, chaotic, and violent, and transforms it into soft, glowing light that drifts across the night sky. Without this remarkable system, the solar wind would strike Earth directly, stripping away the atmosphere over millions of years. The aurora would not exist because neither would the air required for it. Our world would be harsh, empty, and silent. But instead, we live on a planet with a magnetic heart, protected by a shield that converts danger into beauty. Sometimes, when standing beneath a bright auroral display, it's almost impossible to imagine the scale of what is happening. A delicate ribbon of green floating overhead is connected to storms on the sun that are larger than entire planets. A soft shimmer in the sky is the final step of a journey that began 150 million kilometers away. A faint purple arc glowing on the horizon is the result of particles moving through magnetic lines that stretch far into space. It is breathtaking when you think about it. Cosmic violence transformed into peace, chaos turned into calm. And yet, the magnetosphere remains so quiet that we feel none of this directly. The only signs we see are the lights themselves, soft, elegant, silent. Watching them is like listening to a story told in slow motion, where every detail unfolds at a pace meant to soothe the mind. In northern regions, people have learned to read the aurora almost like weather. A sudden brightening can mean a burst of energy arriving from the magnetotail. Waves moving southward can signal that a reconnection event is occurring. Some observers spend entire nights under the sky, camera in hand, waiting for the first hints of green to appear. But even after decades of research, the magnetosphere still holds secrets. There are processes scientists have only begun to understand. There are auroral forms that appear without explanation, spirals that rotate, patches that blink, arcs that split in two and rejoin as if following choreography. No other natural phenomenon is as scientifically measurable, yet emotionally mysterious. And perhaps that is why people are drawn to auroras. They connect the worlds of science and imagination, logic and wonder. They remind us that our planet is not separate from space, but part of it, constantly influenced by the sun's energy and protected by its own magnetic heartbeat. In this chapter, we've walked through the invisible architecture that makes the aurora possible. In the next one, we'll travel closer to the sun itself, exploring how solar storms, flares, and the rhythm of the solar cycle shape the intensity and beauty of the lights we see on Earth. There, on the surface of our star, the story of the aurora truly begins. Every aurora begins with a journey that starts not on Earth, but deep within the glowing heart of our star. To understand the lights that dance across polar skies, we must first understand the energy that feeds them. And that means looking toward the sun, a place that feels distant and unreachable, yet shapes every moment of life on Earth. The sun is more than a bright sphere in the sky. It is a living engine of energy, a colossal nuclear furnace fusing hydrogen into helium in its core. Every second, it releases more energy than humanity has used throughout its entire existence. Yet only a tiny fraction of that energy reaches Earth, and an even smaller portion, almost insignificant in comparison, takes the form of charged particles that eventually create the aurora. These particles make up the solar wind, an invisible stream flowing outward from the sun at extraordinary speeds. The wind is constant, gentle in appearance, like a soft breath across the solar system. But behind its calm nature lies an incredible force. Each particle is born in temperatures exceeding 1,000,000 degrees in the sun's outer atmosphere, the corona. Here, heat is so intense that atoms lose their electrons, becoming charged and free to move. These charged particles, mostly protons and electrons, drift away from the sun, carried outward by magnetic fields. By the time the solar wind reaches Earth, it usually travels at speeds between 300 and 500 kilometers per second. Sometimes faster, sometimes slower, but always present. Yet the aurora does not depend on the gentle everyday wind. The most brilliant lights come from moments when the sun's calm surface erupts. The sun is constantly shifting, twisting, and reshaping itself. Its magnetic fields tangle and snap like enormous rubber bands heated from within. When this happens, bursts of radiation or clouds of plasma can be launched into space. These events come in two forms: solar flares, which release intense bursts of light and energy, and coronal mass ejections, (CMEs), which hurl billions of tons of charged particles outward. A CME is like a giant wave racing across the solar system. When one of these waves is directed toward Earth, it pushes the solar wind ahead of it, compressing and intensifying the flow. The particles within it can travel at more than 2,000 kilometers per second, reaching Earth in as little as 15 to 18 hours. When such a storm arrives, the magnetosphere responds dramatically. The side of the magnetic field facing the sun is pressed inward, while the long tail behind Earth is stretched further and further into space. And when the magnetic tail finally snaps back, releasing all that stored tension, particles rush along the magnetic field lines toward the poles. What happens next is the aurora as we know it, fast, bright, and full of color. But the solar wind does more than create beautiful lights. It also carries information about the sun itself. Scientists study its temperature, speed, and density to predict magnetic storms. Spacecraft orbiting the sun, such as NASA's Parker Solar Probe and ESA's Solar Orbiter, collect data about the solar wind directly, flying through regions no spacecraft had ever reached before. These missions help humanity understand not only the aurora, but the behavior of the sun during its 11-year solar cycle. This cycle is a repeating pattern of activity. During solar minimum, the sun's surface is quiet, with few sunspots and weak flares. Auroras still appear, but they are more gentle and less frequent. During solar maximum, however, the sun becomes stormy and unpredictable. Sunspots multiply. Flares erupt with little warning. CMEs launch into space much more often. These are the years when auroras become intense, bright, and widespread, sometimes even visible in regions far from the poles. Scientists can estimate where we are in the cycle by counting sunspots. A high number of sunspots means the sun is active. A low number means it is resting. This rhythmic behavior has been known for more than 150 years, but we still do not fully understand why the cycle exists or why it sometimes varies in strength. Some cycles are mild, with few storms. Others are powerful, capable of creating auroras visible across entire continents. The most dramatic solar storm ever recorded occurred in 1859. Known as the Carrington Event, it produced auroras so bright that people in Cuba, Jamaica, and even southern Japan saw the sky turn red and green. Telegraph lines, the technology of the time, sparked with electricity and caught fire. If a storm of this magnitude struck today, it would challenge modern satellites, power grids, and navigation systems. Yet even with these risks, the idea that something so powerful can become something so beautiful is astonishing. But most solar storms are harmless. On Earth's surface, we feel nothing. There is no vibration, no sound, no sudden change. Only the sky reveals what has happened, glowing softly in response to solar energy that has traveled millions of kilometers through space. When watching the aurora, It's easy to imagine that these lights are simple, peaceful decorations. But knowing that they began as eruptions on the surface of the sun adds a new level of wonder. It is like seeing a calm river and understanding that far upstream, a great waterfall feeds its flow. Even during quiet times, the sun's influence is present. The solar wind shapes the magnetosphere every day, bending and stretching it, guiding charged particles back towards space or into the auroral ovals. Without this constant pressure, Earth's magnetic field would be static and unmoving. But because the solar wind is always there, the magnetic field becomes dynamic, a living shield shaped by cosmic weather. The connection between the sun and Earth is delicate. Too little solar activity, and the auroras fade. Too much, and the magnetic field becomes disturbed. But somewhere in the middle, in that perfect balance, we find the displays that inspire travelers, photographers, and dreamers. The solar wind also carries secrets about the sun's rotation, its magnetic cycles, and even the structure of the solar system itself. By studying it, scientists can detect distant solar storms long before they reach Earth. This helps satellites prepare, power grids adjust, and astronomers plan observations. It also helps aurora chasers, those who travel the world in search of bright displays, predict when the sky might come alive. Standing under an aurora, created by a strong solar storm, is an experience unlike anything else. The lights move faster, brighter, more unpredictably. They form spirals, curtains, and rays that appear to reach down toward the Earth. Colors shift rapidly, green to purple to pink. The entire sky becomes a living tapestry, a reflection of the sun's heartbeat. And yet, despite all this energy and motion, the aurora remains silent. The sun may roar. The solar wind may race through space at unimaginable speeds. Magnetic storms may ripple across the magnetosphere like invisible waves. But on Earth, the only sign of all this activity is a gentle glow that calms the mind, slows the breath, and reminds us that we are part of a universe far larger than ourselves. The aurora is, in many ways, a cosmic conversation, a dialogue between the sun and the Earth. The sun sends energy across space. The Earth responds with light. And as we continue our journey, the next chapter will explore the colors of the aurora in detail, why the sky glows green, why red lights appear during rare storms, and how the chemistry of the atmosphere paints the night with its luminous palette. When you stand beneath an aurora for the first time, one of the most striking things is not just the movement or the silence, or even the vastness of it. It's the color. Green that glows like emerald mist, purple that burns softly at the edges, red that seems to bleed down from the upper sky like a quiet fire. These colors feel almost alive, shifting as the sky breathes, fading and returning as if stirred by an invisible hand. But the colors of the aurora are not random. They are the result of delicate interactions between charged particles from the sun and the atoms that make up our atmosphere. To understand the aurora fully, we must imagine Earth's upper atmosphere as a giant canvas, one spread across hundreds of kilometers, layered like translucent sheets of air. Each layer has a different density, a different composition, a different temperature, and because of that, each layer paints the sky in its own way. The main painter in this celestial display is oxygen. It may not seem like a colorful element. We breathe it in every moment of our lives without noticing it. But at high altitudes, when struck by energetic particles traveling from the magnetosphere, oxygen glows with extraordinary beauty. The most common color of the aurora, the bright, vivid green seen across northern skies, comes from oxygen atoms located about 100 to 150 kilometers above the ground. When a high-speed electron from the solar wind collides with an oxygen atom, it transfers a bit of energy. The atom becomes excited. holding on to this borrowed energy for a moment. And then, when it releases it, the atom emits a photon, a tiny packet of light, in a very specific shade of green. This green is unique in nature. It's a color rarely seen in other atmospheric phenomena. Not the green of plants, not the green of water, but a pure glowing tone that seems to be made of light rather than pigment. And because oxygen is abundant at this altitude, the green aurora often forms graceful curtains or sweeping arcs that stretch across the entire sky. Higher above, around 200 to 300 kilometers, oxygen produces a different color entirely, a soft, deep red. This red aurora is far rarer than the green variety. It usually appears only during strong solar storms, when the atmosphere is bombarded by more energetic particles. At these extreme heights, the air is so thin that oxygen atoms can hold on to energy longer before releasing it, and the result is a faint, diffuse crimson glow. Some people describe red auroras as eerie or haunting. In ancient times, they were seen as omens of war or fire in the heavens. But to modern eyes, they are simply stunning, a gentle, otherworldly shade that seems to float above the green lights like a separate layer of color. The third major contributor to the aurora's palette is nitrogen. Nitrogen makes up nearly 78% of Earth's atmosphere, yet it often stays silent during normal auroral displays. But when solar activity increases, nitrogen begins to speak in shades of purple, violet, and blue. When nitrogen molecules are struck by high-speed particles, they can emit light in short wavelengths, blue and violet, that give the aurora its shimmering edges. These colors often appear at lower altitudes, below 100 kilometers, where the atmosphere is denser. Because the air here absorbs blue light easily, these colors usually appear only in strong auroras, forming narrow streaks or bright lower borders beneath the familiar green curtains. Occasionally, nitrogen produces a beautiful pink glow, a blend of red oxygen light and blue nitrogen emission. This pink occurs when the two layers overlap in just the right way, creating a soft gradient that looks like dawn rising through the night sky. It's almost as if the atmosphere itself is blending the colors, like a painter who brushes two tones together to create something new. But the aurora's palette is even more complex. Some rare displays show white auroras, the result of multiple wavelengths overlapping so perfectly that they appear colorless to the human eye. Others show yellow or orange, subtle variations created when green and red emission lines mix. And then there are the most mysterious forms, colors that shift faster than the eye can follow. Scientists still debate the exact mechanisms behind some of these lights, especially those appearing during violent geomagnetic storms. Even with modern instruments, cameras, and satellites, auroras continue to surprise us. To understand why different colors appear at different heights, we must consider how atoms behave in the upper atmosphere. The atmosphere becomes thinner as you go higher, meaning atoms are spaced farther apart. When an oxygen atom at 250 kilometers is excited by a charged particle, it can hold on to that energy for several seconds before releasing it as red light. If the same atom were lower in the atmosphere, it would collide with another atom too quickly, losing the energy before it could emit light. And so, red auroras form only in the thin, lofty reaches of the sky. Green light, on the other hand, is released much faster, in just a fraction of a second. That's why green forms in denser regions 100 kilometers above Earth. Nitrogen behaves differently still, with its emissions depending on both altitude and the energy level of the incoming particles. All of this means the aurora's colors are not just beautiful, they are clues. Clues that reveal where in the atmosphere the lights are forming. Clues that hint at the intensity of the solar wind. Clues that show how our planet responds to storms from the sun. For scientists, an aurora is a data-rich event, Observing its colors helps them understand the structure of the upper atmosphere, detect space weather disturbances, and even study how Earth's magnetic field is shifting. But for ordinary observers, for travelers standing under a sky that glows, the colors mean something different. They mean presence. They mean wonder. They mean that a distant star has reached across space and touched our world with light. Imagine watching the aurora from a quiet field of snow. The ground is white and still, muffling every sound. The night is cold enough that your breath hangs in the air like smoke. Above you, green curtains drift like slow-moving waves. Then, at the horizon, a faint red glow begins to grow, rising like a gentle fire spreading across the sky. Purple streaks appear at the edges, shimmering softly as if the sky itself were exhaling color. No sound, no rush, no urgency. Only the slow, silent motion of light created by the interaction between the sun and our fragile atmosphere. Even after centuries of scientific study, the aurora remains a deeply emotional phenomenon. It connects physics to beauty, chemistry to poetry. It reminds us that the universe is not only vast and powerful, but also capable of creating delicate displays of color that inspire calm and reflection. And while the colors we see are shaped by atoms and energy, the feeling they create, that sense of awe, of peace, of connection, is something beyond science. As we move forward, the next chapter will explore something equally fascinating: the stories and legends that ancient cultures created to explain these lights long before we understood the physics behind them. While science explains the how, mythology reveals the human heart, the way people across history made sense of the sky when it came alive with color. Long before we understood solar winds, magnetic fields, or atmospheric chemistry, people looked up at the night sky and tried to explain the aurora in the only way they knew how: through stories. When the heavens began to glow, when colors shimmered across the horizon with no warning, ancient civilizations felt both wonder and fear. And so, over thousands of years, cultures from every corner of the northern world created legends. Some comforting, some haunting, all deeply human. Tonight, let's walk slowly through these stories, as if sitting by a fire while the sky dances above us. The whispering lights of the Arctic peoples. For the Inuit of Alaska and northern Canada, the aurora was more than a beautiful sight. It was a connection between the living and the dead. They believed the lights were the spirits of ancestors playing in the night sky. Some stories said the spirits were playing a sort of celestial game, tossing a ball made of walrus skulls back and forth. When the aurora moved fast or flickered, it was said the spirits were laughing, running, or chasing each other across the stars. In other Inuit communities, the lights were thought to be guides, gentle, protective beings who watched over travelers in the harsh Arctic night. People believed that if you whistled to the lights, they might come closer, dancing above you. But if they came too close, they could reach down and take you with them, lifting you into the sky. So the Inuit learned to watch the aurora with a mix of delight and caution, treating it with both respect and affection. In the stillness of Arctic winters, when daylight disappears and the world sleeps under ice, these stories offered comfort. The aurora wasn't a threat. It was company. The Norse lights, shields of the Valkyries. In Scandinavia, the Vikings saw the aurora as a sign of battle and power. They believed the shimmering lights were reflections of the Valkyries, warrior maidens who rode across the sky on horses made of wind and storm. Their armor shone so brightly that it lit up the heavens. These Valkyries carried the souls of fallen warriors to Valhalla, the great hall of Odin, where heroes would feast and fight until the end of time. Some legends describe the aurora as the breath of the Valkyries or the glow of their spears. When bright red auroras appeared, rare and intense, they were seen as omens of war. The sky became a battlefield painted by the gods. And yet, even in these fierce myths, there was beauty. To a Viking standing on the deck of a ship, the dancing green lights above the North Atlantic must have felt like a promise that the gods were watching, guiding them across dangerous seas. The Finnish firefox. Finland has one of the most poetic explanations for the aurora. According to Sami and Finnish tradition, the lights were created by a magical creature called the Ravontuli, the firefox. This fox ran so quickly across the snow that its tail brushed against the mountains, sending sparks up into the sky. Those sparks became the aurora. In some versions, the fox's tail was made of frost that glowed when it moved. In others, the fox itself was made of fire, leaving trails of light behind it as it ran. The idea that an animal could paint the sky with sparks is one of the most gentle and imaginative interpretations of the aurora ever recorded. Even today, the Finnish language still uses the word revontulet, meaning foxfire, to describe the northern lights, the Japanese tale of good fortune. In Japan, the aurora is rare, but when it appears, it is considered a powerful sign of luck. A traditional belief says that children conceived under the aurora will be blessed with good looks, intelligence, and a long, prosperous life. Couples who traveled north in hope of seeing the lights often saw them not just as a natural wonder, but as a blessing. There's something deeply romantic in this idea. Two people standing together under a sky that glows softly above them, believing that the moment carries magic. The Cree and the dance of spirits. Among the Cree people of Canada, the aurora was seen as the dance of the spirits. Unlike the Inuit, who sometimes viewed the lights as the spirits of ancestors, the Cree believed the lights were the spirits of all people, past, present, and future, celebrating life together in the sky. Some elders taught that when the lights moved slowly and gracefully, it meant harmony and peace. But when they danced quickly or flickered sharply, it was a sign that the spirits were excited or trying to send a message. The Cree did not fear the aurora. They saw it as a reminder that we are all connected, that life continues beyond what the eye can see. The Roman and Greek skies. While auroras are rarer in southern Europe, ancient Romans and Greeks did witness strange lights in the sky during strong solar storms. Lacking a word for the phenomenon, they interpreted it as fire in the heavens. Pliny the Elder, a Roman naturalist, wrote about glowing skies that appeared before earthquakes or conflicts, fueling the belief that celestial lights were omens from the gods. The Greeks believed the lights were the reflections of Artemis's silver chariot, or the armor of Athena shining before battle. The aurora was not common there, but when it came, it brought with it mystery and unease, the Chinese dragons of light. In ancient China, celestial lights were often associated with dragons, symbolic creatures of power, wisdom, and transformation. Some Chinese legends describe the aurora as dragons fighting among the stars, breathing fire and color through the night sky. Others say the lights were heavenly banners waving in the wind, signs that the celestial realm was celebrating an event unknown to humans. These stories blended astronomy, myth, and philosophy, reminding people that the universe was full of forces greater than themselves. A common thread through all stories. If you truly want to see the aurora in all its quiet splendor, you must first accept the invitation of the night. The aurora never appears in places that rush. It prefers silence, patience, and stillness, as if it chooses those who are willing to meet it on its own terms. And for many travelers, the journey toward the northern lights becomes just as memorable as the moment they first appear. People often say that the first place you really see the aurora isn't a point on a map. It's a feeling inside you. It's the moment you decide to leave behind the noise and step into the colder, slower parts of the world, where the sky grows deeper, the air sharper, and the world moves with a gentler rhythm. Still, there are places on Earth where the chances of seeing the aurora rise so much that they almost become a promise. The Arctic Circle is home to the brightest auroras. Within this invisible ring lies the region where Earth's magnetic field bends downward, guiding particles from the sun directly into the upper atmosphere. It creates a shimmering belt that sweeps across the northern world, connecting countries that share the same quiet magic. Norway is one of the most beloved destinations. Cities like Tromsø feel as if they were built specifically for watching the aurora. During winter, the nights stretch endlessly, creating a perfect darkness that waits patiently for the sky to awaken. The mountains, the frozen beaches, the stillness of the fjords, everything adds a kind of calm that makes the appearance of the lights even more striking. Sometimes the aurora appears right above the city. Other times you must travel a little farther, up the hills, where the glow of human lights no longer touches the night. In Finland, stillness becomes part of the experience. The small villages of Lapland, covered in soft snow and surrounded by pine forests, offer one of the most intimate encounters with the aurora. Many cabins have glass roofs so you can lie in bed, wrapped in warmth, watching the sky shift and breathe with slow colors. It is a quiet, private kind of wonder, perfect for those who want not just to see the aurora, but to feel its presence as a companion in the long Arctic night. Iceland brings a dramaticness unlike any other place. Here, the land is young, shaped by fire and ice, and the sky reflects that spirit. Lava fields, frozen waterfalls, geysers, and rugged coastlines create a backdrop that makes the aurora look almost like a continuation of the Earth's own energy. Sometimes, the lights come softly, like a thin ribbon drifting above the horizon. Other nights, they erupt into swirling patterns that feel almost otherworldly. Travelers who have watched them from lonely roads or from the quiet outskirts of small towns describe each night as unique, like a secret whispered only once. Canada offers a more solitary kind of beauty. In the Yukon and Northwest Territories, the wilderness stretches endlessly, and you may feel as though you have the entire sky to yourself. The silence is deep, the cold crisp and sharp, and when the aurora appears, it often feels wide, powerful, and incredibly pure. People speak of standing in the middle of snow-covered fields for hours, unable to look away, watching the lights shift in slow, graceful waves above them. Alaska carries its own sense of legend. The sky feels higher there, more open, especially far from the main towns. Fairbanks is famous for its visibility, but the true magic happens when you leave the roads and enter the remote areas, places where only the snow, the cold, and the stars keep you company. When the aurora rises over these vast spaces, it feels ancient, untouched, and profoundly moving. Even Greenland, with its harsh climate, rewards visitors with lights that seem unusually intense. The darkness in many areas is so deep that the colors appear sharper and more saturated, as if the aurora has been painted directly onto the sky. Many travelers describe the experience as spiritual, not because they understand more of the universe, but because they feel something humbling and beautiful in the vast silence. And yet, the aurora can travel far beyond the Arctic Circle. During strong geomagnetic activity, it can dip into northern Scotland, the northern United States, parts of Russia, and even southern Sweden. These moments are rare and often surprising. People step outside to take out the trash or return from work, only to find the sky glowing faintly above them, an unexpected gift that stays in their memory for years. But places alone do not guarantee the lights. The conditions must align. The night must be clear, free of clouds, with no artificial lights nearby. Fields, open lakes, mountains and quiet forests all offer the dark canvas the aurora prefers. When there is no light pollution, your eyes can adjust and see even the palest green or purple movements spreading across the sky. And then there is patience, the most important tool of any aurora seeker. Sometimes you wait for hours in the cold. You breathe small clouds into the air, shift your weight from one boot to the other, and wonder if tonight will remain just a quiet night. And then, slowly, a faint green tint appears low on the horizon. At first, you're not sure if it's real, but it grows, soft at first, then deepening, stretching upward like a quiet breath of the earth. That first moment, when the light reveals itself, is enough to make all the waiting worthwhile. The aurora has a way of transforming landscapes. A valley you walked through during the day becomes unfamiliar and enchanted at night. Mountains turn into dark silhouettes, and the snow reflects the light so softly it feels like standing inside a dream. Whether you are by a frozen lake in Norway, in a Finnish forest, or on an Icelandic plain, the feeling is the same. You step into a world that feels between two realities. And maybe this is the secret of the best places to see the aurora. They are not only locations on a map, they are places where you meet a quieter version of yourself, places where the sky becomes a patient teacher and the light becomes a language you understand with your heart more than with your eyes. Wherever the journey takes you, the aurora always seems to remind you of one thing: the world can still surprise you, gently, silently, beautifully, if you are willing to look up. There is a quiet irony in the northern lights. For most of us, the aurora is a gentle show of color, something to watch and feel small beneath. Yet behind that softness lies a powerful interaction between the sun and our planet. An invisible dance of particles and fields that sometimes reaches down and touches our modern technology. The very forces that paint the sky can also disturb the electric world we have built, and understanding that connection helps us live more safely beneath the lights. When the sun grows restless, it sends waves of charged particles toward Earth. Most of the time, our magnetic shield catches them and creates the delicate auroral glow. At other times, during stronger solar storms, far more particles arrive, and they do more than simply brighten the sky. They push and pull at magnetic fields, create currents in the upper atmosphere, and launch electrical effects that travel along the ground as if the planet itself had become part of a circuit. These ground currents are known as geomagnetically induced currents, and they are the hidden link between the aurora and many modern problems. Power grids are among the systems most sensitive to these invisible currents. Long transmission lines act like giant antennas, picking up slow variations in Earth's magnetic field. During a severe geomagnetic storm, these induced currents flow into transformers and high-voltage equipment, quietly driving them toward overheating or failure. In March 1989, a storm of this kind caused the entire province of Quebec to black out within minutes. Transformers were damaged, and people woke to find cities dark in the middle of the day. That event taught grid operators around the world a vital lesson. Beautiful skies can arrive with serious consequences, and the electrical backbone of modern life needs protection. Satellites are also vulnerable. They orbit in regions where charged particles concentrate, and during strong solar events, those particles can buffet electronics, degrade solar panels, and cause temporary malfunctions. A satellite might put itself into safe mode when sensors detect unusual radiation, interrupting communications or navigation services. Satellites that provide weather data, television, or GPS positioning may be affected for hours, sometimes days. For aircraft relying on long-range communication, this can complicate flight routes, especially over polar regions where high-frequency radio is commonly used and where the auroral effects are strongest. Radio communication itself can wobble under auroral influence. High-frequency radio signals bounce off layers of the ionosphere to travel long distances. But the aurora is a disturbance in that same ionosphere. The increased ionization and turbulence created by incoming particles can scatter, absorb, or shift radio waves, causing static, fading, or outright loss of signal. For communities in remote northern regions, or for ships and aircraft crossing polar routes, that interference is more than an inconvenience. It can be a safety issue. Pilots, mariners, and emergency responders monitor space, weather alerts for this reason, changing routes, or communication methods when needed. Pipelines may seem far removed from the sky, but they too feel the aurora's effects. Geomagnetically induced currents can travel through the Earth and find their way into long metal structures like pipelines. These currents can accelerate corrosion, subtly weakening protective coatings and increasing maintenance needs. Engineers watch for these effects and use cathodic protection systems and monitoring to reduce long-term damage. But the aurora's quiet reach reminds us that even buried infrastructure is not entirely shielded from cosmic weather. There is also an agricultural and ecological side to consider. The aurora itself does not harm crops, but the disruptions it causes to communication networks, satellite imagery, and navigation systems can interfere with precision agriculture, timing, and monitoring. In remote regions, indigenous communities that rely on radio for weather and safety can be affected by sudden communication blackouts. For many of these communities, the aurora is part of daily life. The balance between its cultural presence and its technical disruptions is delicate. Modern life has also turned the aurora into a service industry. Aurora tourism is a growing economy in places like northern Scandinavia, Iceland, and Canada. People travel at night into quiet, remote landscapes, pay for guided tours, and sleep in glass igloos to watch the lights. This has brought income and jobs to remote communities, but it also means those same communities rely on the technologies that the aurora can unsettle: satellite-based bookings, online weather forecasts, GPS-guided transport, and even emergency services. The lights bring both economic opportunity and a responsibility to plan for space weather risks. Science benefits from auroral disruptions too. The same energetic particles that bother our electronics provide rich data for researchers studying the Sun-Earth connection. Monitoring networks of magnetometers, satellites that watch solar particles, and arrays of ground-based instruments help scientists predict storms and understand how our planet responds. Forecasting has improved. Agencies now issue warnings when a coronal mass ejection is headed our way, and operators can take protective actions, temporarily rerouting flights, powering down sensitive equipment, or putting satellites into safe mode. Instruments like the Discover satellite at the L1 point give early warning of incoming solar wind, providing a precious lead time measured in tens of minutes to hours. Industry has learned to adapt. Power companies install blocking devices, reconfigure lines, and adjust operations to limit the flow of geomagnetically induced currents. Satellite builders harden electronics and add shielding. Airlines avoid risky polar routes during major storms, or they switch from high-frequency radio to satellite-based alternatives when needed. Pipeline operators monitor corrosion rates and use engineering solutions to mitigate effects. The invisible dance of particles has pushed human systems to become more resilient. There are also subtle psychological and cultural effects. When auroras arrive alongside news of satellite outages or communication disruptions, people feel both awe and a small, rational unease. The skies that inspire quiet reflection also remind us of our technological fragility. Yet that tension is productive. It encourages investment in better forecasting, stronger infrastructure, and international collaboration on space weather. Countries share alerts and strategies because the sun's influence ignores borders. And finally, not all aurora effects are negative. Scientific instruments aboard satellites and in observatories gain precious opportunities to study extreme space to weather events. Data collected during storms improves models that protect grids, satellites, and navigation systems. The aurora itself draws people into science. Tourists become amateur meteorologists, photographers learn about exposure and color, and children inspired by a glowing sky sometimes follow careers in astronomy, engineering, or environmental science. So when you stand beneath the lights, remember this complex balance. The aurora is both gift and reminder. Gift of beauty and extraordinary natural spectacle. Reminder that our modern world is delicately woven with invisible threads. The same cosmic breath that paints the night can nudge a transformer, confuse a radio, or move a tourist to tears. As technology advances, we learn to listen more carefully to the sun and to weave resilience into our systems so that the invisible dance of particles remains, for most of us, a quiet, comforting show, one that delights without disrupting, that teaches without frightening, and that, in its gentle way, connects us all to the larger rhythms of space. There is a quiet truth about the aurora. No matter how much we learn, no matter how many instruments we build, or how precisely we map its patterns, it continues to touch something deep within us. It is a phenomenon that blends science and emotion in a way few things can. You can know every detail of how it works, the solar winds, the charged particles, the magnetic field lines. And still, when the sky begins to glow, all that knowledge quietly steps aside, making room for wonder. Part of the aurora's eternal beauty lies in its unpredictability. You can wait for hours, under a dark, silent sky, watching the stars hold their positions, the cold growing sharper with each passing minute. And then, without warning, a faint haze appears on the horizon. It doesn't announce itself. It doesn't rush. It simply grows, like a thought taking shape. A soft line of green becomes a curve, and the curve becomes a drifting ribbon of light. This quiet arrival feels almost alive, as if the sky were breathing in color. Even when you think you know what will happen next, the aurora surprises you. It shifts from a gentle arc into a curtain rippling across the sky. It expands like a rising tide, then breaks into vertical rays that stretch upward, as if reaching for something hidden beyond the stars. Sometimes the lights surge suddenly, as though the night has been struck by an invisible pulse. Scientists call this an auroral substorm, but from the ground it feels like witnessing a transformation, like watching the sky decide to awaken. And then there are the colors. Most people see green first, the familiar shade born from oxygen in the upper atmosphere. But on rare nights, the aurora deepens into red, or softens into purple, or spills sideways into blue edges that look almost unreal. These colors remind us that the sky has layers, each responding to the sun's distant breath in its own way. Even if you know the chemistry behind them, they feel like gifts, brief, fragile, and unforgettable. The aurora's beauty also lies in its movement. It doesn't behave like anything else in nature. Water has its waves, fire has its flicker, wind has its patterns. But the aurora moves in ways that seem both physical and intangible at once. It glides, it folds, it twists gently, it stretches suddenly, then dissolves as if made of air. When it dances, it does so without sound. Yet every motion carries a rhythm you feel more than hear. People often describe its movement as otherworldly, but at the same time, it is deeply connected to Earth itself, shaped by the invisible magnetic paths that surround our planet. And then the aurora touches something human, something older than science, older than memory. For thousands of years, people looked at these lights with a mixture of awe and reverence. They saw in them the presence of ancestors, the spirits of animals, the fires of distant realms. And even though today we have explanations grounded in physics, those ancient feelings linger. The aurora awakens a part of us that is quiet, reflective, and deeply aware of our place in the universe. It reminds us that knowledge does not erase mystery, it only makes it richer. There is also beauty in the conditions that surround the aurora. To see it clearly, you must step into the quiet. You must leave behind the noise of cities, the glow of artificial lights, and the rush of daily demands. You find yourself standing on frozen ground, or on a silent hillside, or beside a still lake that reflects the night sky like black glass. In those moments, the world feels older and more patient. The air is cold against your skin. Your breath forms small clouds that disappear as quickly as they come, and the darkness around you becomes a comfort instead of a fear. The aurora doesn't just light the sky, it changes the entire landscape of your awareness. And in that stillness, something in you softens. The mind becomes quieter. The worries of the day become distant. You are no longer thinking about what happened before or what will happen next. You are simply there, present, watching colors move across the heavens. This sense of presence is part of what makes the aurora timeless. It gives you permission to pause, to breathe, to feel small in a way that is peaceful rather than overwhelming. Science adds its own kind of beauty to the experience. Knowing that the lights above you are the visible trace of Earth interacting with the sun creates a sense of connection. The aurora becomes a reminder that our planet is part of a larger cosmic choreography. It shows you that solar storms many millions of kilometers away can paint the sky above your head. It reveals that Earth's magnetic field, silent and unseen, is constantly shifting and protecting you. This perspective is not cold or mechanical. It is comforting. It tells you that you are part of a world shaped by rhythms far older and larger than daily life. And then there is the emotional imprint the aurora leaves behind. People who witness it often describe the feeling long after the lights fade. They remember the way the horizon glowed. They remember the way the colors shifted, the way the sky seemed alive. They remember the sense of peace, the quiet excitement, the awe that washed over them. These feelings stay with them for years, sometimes forever. The aurora becomes a personal memory, a moment of clarity or calm that they can return to whenever life becomes too loud. This lasting impression is one reason why the aurora continues to fascinate generation after generation. Even as technology advances, even as satellites map the lights in perfect detail, the human response remains the same. It is the same feeling that explorers wrote about centuries ago, the same feeling that ancient cultures tried to describe through stories and myths. The aurora has changed very little, and neither have we. And perhaps this is the essence of its eternal beauty. The aurora connects the past and the present. It reminds us that we share the same sky as the people who lived long before us, and that we will pass that same sky to the people who come after. Every time the lights return, they continue a story that has been unfolding for thousands of years, a story not of facts alone, but of emotion, curiosity, and quiet reflection. When the aurora finally fades, when the colors soften, dim, and slowly disappear into the darkness, there is a gentle sadness, but also a sense of completion. You know the lights will come back, maybe tomorrow, maybe months from now, maybe next year. Yet the memory of the moment stays with you, glowing softly in your mind, like an ember that never fully goes out. And so, the aurora will never stop captivating us. Not because it is mysterious, or rare, or scientifically complex, but because it speaks to something deep and universal. It touches the places in us that remain quiet and hopeful. It brings perspective to our small lives without diminishing them. It reminds us of connection, of rhythm, of the beauty woven into nature's design. The aurora dances without asking for attention, but once you have seen it, you carry its light with you. You remember the way it moved, the way it filled the night with color, the way it made everything feel gentle and eternal. And that memory is perhaps the greatest gift the aurora offers, a moment of stillness in a restless world, a moment that stays with you long after the sky grows dark again. Thank you for joining this quiet journey through the lights of the aurora. If you're still awake, take a slow breath, maybe a small sip of water, and let your body sink deeper into rest. And if you enjoy these relaxing documentaries, you're welcome to subscribe to the channel so you can return anytime to new stories made just for sleep. A gentle like also helps this peaceful content reach others who might need a moment of calm tonight. For now, let the silence carry you. Good night.